Hello, everyone. Thank you, Dr. Badai, for the introduction. Hello, good to see you guys here. First of all, we were supposed to have another session on logistic regression from scratch. We had to cancel because of my schedule. Sorry about that. I'm hoping to have that session later. So we are going to have another session on building logistic regression from scratch. But today, as we promised earlier, we are going to work on Kmeans clustering. So there are a couple of algorithms that we need to be familiar with as beginners of data science, right? So linear regression, logistic regression, and K-neighbors classifier / regressor. So these are three supervised models that any data scientist, beginning his journey or her journey on data science should know. And I think it makes sense to know how to build these algorithms from scratch with Python. You can do it with R, but here we're gonna do it with Python. In addition to those supervised models, as an unsupervised model, I would say K-means clustering is one very basic algorithm that we need to be familiar with. So today, that's what we're going to learn. The idea is very simple. There is no file that I need to share with you now. We're just going to type the code. Normally, let me share my screen first before I forget. The other time I forgot about it. Yeah, I hope you guys can see the screen. And if you have any questions, you can post it to Q&A. Okay, please post your questions to Q&A. At chat, there are a lot of messages. I'm missing the questions from time to time. So normally, what I suggest is if you want to practice building code from scratch for any algorithm, do it with just a blank paper or on the board. So don't worry about the syntax. Don't worry about whether the code is going to be running smoothly. So that's another story. So first of all, you need to know at a high level the building components of that algorithm. But then, if you really want to write the code and then run it, execute it, then you need to spend some time because you will see that you're going to receive a lot of errors. The code, even though the code at a high level is correct, you are going to forget 1 comma, 1 dot, or sometimes the dimensions of the arrays are not going to be in agreement. So then you're going to have a lot of errors, and that will take some time. And it's a very good practice actually for coding. So again, any data scientist lacking coding skills, I don't know how he or she can succeed in data science. So you have to have coding skills, and there is no other way but you have to code to learn coding. Okay, so you have to sit down and then just type the code. So again, today there is no file that I'm going to share you. We're just going to do it together, step by step. So first of all, let's remember what K-means clustering is. First of all, K-means clustering. Okay. It's an unsupervised model. Okay. What does that mean? So it means. Sorry. So it means we don't need the labels. It's not that we don't want the labels, but there are some occasions that we are not going to have labels. We only will have the data. And we need to cluster this data into groups. Say you have groups of customers, you don't have what kind of customers these people are. And then based on some characteristics of these customers, you are going to put them into groups, into clusters. So then the next question is, how are we going to put them into clusters? So when we are placing the customers or data points, let's make it more general, data points into clusters, what we are going to use we are going to use a metric. Use a metric to determine in which cluster a data point belongs, right? So we need to have some metric. So based on what we are going to decide that this data point belongs to this cluster or that cluster. So as a metric, today, we are going to use Euclidean distance. Okay, so that is what we are going to use. Then the question is, what is Euclidean distance? So let's say we have 2 points. So data one point, and then let's say our data points have 2 features, x1 and x2. Okay, this is data one. And I have another data point, d2. This is x1. Let's make this x1, 1, x1, 2. So this is the first data point, x1, 1, x1, 2. And this is the second data point, x2, 1 and x2, 2. Okay, so we have 2 data points with 2 features. Imagine that these data points are placed on a coordinate system in 2 dimensions. And then we have 2 data points, and we want to measure the Euclidean distance between these 2 points. So then the distance is, right? Again, remember this from your maybe middle school or high school mathematics, right? The distance is going to be square root of, right? Take the difference between x11 and x21, means you first focus on one dimension, take the difference in that dimension, and then take the square root of that. Let's do it. x11, I'm taking the first dimension of the first feature of data point 1, and then first feature of data point 2, and then take the square root of this, right? Plus, I'm going to repeat this for the second feature, x12 minus x22, and then take the square. And then square root of this addition, the summation will be the distance. All right, so based on this distance, I'm going to decide whether a data point belongs to a certain cluster. Okay, but then what is this distance? So let's say I have one data point. So, I mean, between this data point and what? So am I going to measure the distance? Okay, so I will measure the distance between each and every data point and the centroids, or let's call it centers. Okay, centers of the clusters. Okay, so again, what is center of the cluster? Center of the cluster is going to have, in this case, following this example, center of the cluster is going to be a point in that 2-dimensional coordinate system, which is going to have 2 features. Okay, so center of the cluster is, imagine it's one of the data points. Okay, it doesn't have to be one of your data points, but it's one of the points on that coordinate system. Okay, all right. Then the question is, so I'm asking questions. So the question is, how many clusters? Or do you, let's first ask this question. Do you know how many clusters you will have? Okay, so because we don't have the labels, right? And this is an unsupervised model. Do we know how many clusters we are going to have? Or do we know into how many clusters I'm going to place these data points? The answer to this question is, most of the time, I don't know. Okay, I don't know how many clusters. Sometimes you might know based on some experience from earlier, but let's say I don't know the clusters. I don't know how many clusters I'm going to put my data points into. Then they are going to start from somewhere. Okay, let's start. Let us pick our best guess. Okay, a number for clusters. Okay, let's call this K. So I'm going to put my data into K number of clusters. Okay. Then the next question is, where are those clusters? Okay, so I don't have any clusters at the very beginning. I don't have any clusters at the very beginning. What I'm going to do is pick random points from your, in this case, 2-dimensional system. Pick K random points from your 2-dimensional system as your initial locations of centers, as your initial centers of clusters. Let's call it that way. Okay, So initially, you don't know where your clusters are. Where is the center of your clusters? First of all, you decided I'm going to have k number of clusters. And then you don't know where the centers of these clusters. So data points will be clustered. And the mean of the data points in the same cluster will be the center. But as of now, you don't know which data point belongs to what cluster. Then how do you know what is the center of each cluster? Then you're going to just pick some random centers, okay, that you're going to assign your data points based on the distance between that data point and each cluster center. So we're going to pick k random points, which are going to be the initial centers of the clusters. Then what? We are going to assign, okay, data points to these random cluster centers based on the distance between the data points and the clusters. Sorry for the... Okay, so I picked k number of clusters, some random centers. Now I'm measuring, let's pick one data point, and there are 5 clusters, let's say. I'm measuring this data point, the distance between those 5 clusters, okay? And then pick the minimum. Pick the cluster with the minimum distance between a data point and the clusters to assign that data point to a cluster. Okay, so I'm going to measure the distance between this data point and all these 5 clusters. So whichever gives me the minimum distance, I'm going to assign this data point to that cluster. Okay, so this is going to handle the initial assignment of my data points to some clusters. It's going to be totally random at this point and may not make any sense, which is okay. Next, we will calculate the cluster center based on the data points we assigned to the clusters or to that cluster. Okay, so now we assign data points to clusters randomly. Now I have n number of data points, n number of data points in one cluster, n number of data points in another cluster, l number of data points in some other cluster. So what I'm going to do is I'm going to take the average of data points in that cluster. That average will be the center of the cluster. So once I find this center, now it is not random anymore, right? So it has some information, okay? I'm going to repeat this procedure. So now I have new cluster centers. Okay, go to step, let's say 2. So let's say this is step 1. This is step 2. Let's say this is step 3. Go to step 3. This is step 4. So we are going to go back and forth between 3 and 4, 3 and 4, until we are going to do this. Go to step 3. Okay. Go between step 3 and 4 for a number of iterations. Okay, so that is how we are going to decide to which class our data points will be belonging to. Okay, so this is basically the idea. It's very simple. Start with some random cluster centers, assign the data points to those clusters based on the distance between each and every data point and the center, and then find the new centers by taking the average of the data points within that cluster, and then again assign data points to these new clusters based on the distance between data points and the new centers, and then find the new center. So back and forth, repeat this procedure for a number of iterations. Actually, after some number of iterations, you will see that data points are not changing their clusters anymore. So you are stabilized, and then you're just going to stop. Then the question is, the cluster number we picked at the beginning, which is k, was this correct, right? So what if our data point was actually in 6 clusters, but we picked 5? So then we are going to do this for different number of clusters, and then we are going to evaluate the model performance on different number of clusters. We'll pick the one based on whatever metric we are using. We'll pick the one that is giving us the minimum, let's say, minimum cost of not being able to cluster data points correctly. Okay, so that is the general overview of K-means clustering. Now let's begin. Okay, let's begin. So first of all, I need some function to find the distance. Okay, so let's try to put things in order. So I need a function for distance. Let's call some class. Okay, say K-means. Okay, I'm just going to call my class as K-means. Remember from our last time, class is a collection of functions which are related. Okay, let's call it attributes and functions, collection of functions which are related. So I need a helper function which is going to help me find the distance between 2 data points. Okay, so then I'm going to need a function for finding the distance. Let's call it find distance. Okay, all right. Then in addition to this function, I'm going to also need a function to fit my data points. Fitting means I'm going to assign my data points to different clusters. So in addition to this, I will also need a function to predict. Okay, so but if I receive a new data point, I already determined the clusters based on my training data set. So how am I going to decide to which cluster this data point belongs? Okay, then I'm going to use predict. I also try to write the code for finding the K, which K was the best. So I don't want to get into it, so I couldn't finish it. I finished, but I have to test it a little bit more. So I'm not going to get into it now. All right. So find distance, fit, and predict. So what I'm going to do is between find distance and fit. Again, if I were writing this on a paper or on the board, it will be much more easier. I wouldn't really worry about array dimensions or any syntax. But because I want to run this code after I write the code, I want to execute it. So I'm going to be extra careful, and it's going to take some time. So please bear with me. All right. So let's begin with find distance. The goal is writing a function which is going to find the Euclidean distance between 2 data points. So what are the parameters that I'm going to pass for finding the distance? For first of all, because this is a class, I will have this construct, right? So this built-in function in it, which is going to be running every time I create an instance from this class, right? Okay, so let me finish this one. So for this, let's say self, right, is going to be pointing to the instance itself. And then let's say I'm going to be starting with some number of clusters. It can be 10. So I'm going to be expecting an input from the user. But right now I'm just assigning an initial value of 10 for number of clusters. And then I'm going to be running this for a certain number of iterations. Let's say it is 50. And then let's also pick some random states so that we are going to have the same set of random numbers. Okay, now let's assign K to 10 and then number of iterations to number of iterations and then random states. So this just takes care of the very initial values whenever I call. So the way this is going to work is somebody is going to give us a set of data points. Let's call it X. And then we are going to create, we are going to instantiate K-means. Okay, some K means 1. This is one instance of K means, and then let's say I'm going to be testing for 5 clusters, and then I'm going to say number of iterations is, let's say, 1000. Okay, so I'm gonna instantiate, get one instance from my class, and then I take this class and fit it for this data set. Okay, that's what I'm gonna do. So Edward is saying, in many of my advanced set, one of the initial things to do was use wetware to check that. That is, look at the data, even try to give a quick plot, maybe sample a large data set plus some of the points. Do you think that is a reasonable set of steps to determine some of the parameters, like number of classes, minimum distance before? Of course, Edward. Every time we deal with any data set, okay. So supervised or unsupervised, it makes, I mean, not just sense, but I think it is a must to look into data set, so plot the data set. Maybe you are going to see the clusters right away. So you're going to see that the data is already clustered. Then you will have a good idea about how many number of clusters you should actually be to begin with. Okay, that also might give you an idea about what kind of distance metric is going to be more helpful, right? So again, I'm not going to get into it, but there are certain distributions of data points that K-means clustering is not going to work. So K-means clustering is assuming that we are going to cluster data points within a circle surrounding the center. Okay. So what if data points are like following really irregular shapes? Then it's not going to be so easy for me to cluster them correctly using K-means clustering. Again, this is a very basic unsupervised model, but it is extremely helpful. Okay. Self K is K. Correct. Thank you. Thank you, Edward. All right. So this is how we're going to work. All right. So here, fit. When I call fit is going to use this find distance function. So I need to come up with find distance function to make this work. So let's work on find distance function. Can we use K-means on categorical variables? Yes. I mean, you can work on categorical variables, but you need to turn them into, you need to encode them into numbers first, right? Yeah, sure, you can use them for categorical variables as well. Okay, so find distance. So what I'm going to do is I'm going to find the distance between 2 data points, x1 and x2, as I tried to explain in here. So here I said D1 and D2. Let me use D1 and D2. So it's going to be better in terms of, okay. Because I'm going to have multiple classes, multiple clusters, each cluster will have its own center. So what I'm going to do now is with this find distance, I'm going to, let's say I got, what is that? D1. So D1 is, let's say, a single data point, and D2 is set of the centers. So a list of centers. Let's say I have K number of clusters. So D2 is, let me write it and put it here. D2 will be a list of, okay, centers. Let's say this is X11, let's call it center. C11, C12. And this is C21, C22, and this, let's say, C31, C32. So, come on. If you have 3 clusters, these are the centers of the clusters. So D1 is one data point. I'm trying to determine what is the distance between this data point and each and every center of the clusters. Okay. Thank you. Yeah, as I said, it's when you write the code, it's going to take, I make a lot of mistakes when I type the code, so it's going to take time to really make this work. It's a very, what is that, a difficult task to write the code and execute it during a live session. Okay, it's going to take some time. So let's find the distance again between each one data point and centers of the clusters. So for that, I'm going to, by the way, this code is going to be very slow. So you need to really, you need to work on this code to make it faster. Okay. But anyways, we're not worried about speed for now. So distances will be an empty list. This list will be holding the distance between D1 and each center. Okay. So let's run a for loop. Okay. That's where the slowness may come in. So you can do this without for loop, but anyways. So I'm going to run a for loop for as many as my number of clusters. Again, D2 is centers of the cluster. So if you do this, if you do D2 dot shape, this is going to be giving you, in this case, shape will be K by 2, right? So K is number of clusters, 2 will be number of attributes. So if you have 2 attributes, it's 2 attributes. If you have 5 attributes, it's going to be 5 attributes. So for I in the range of D2 dot shape 0. So D2 dot shape 0, D2 dot shape 0, in this case will be K, which is number of clusters. So what I'm going to do is I'm going to run a for loop, and then this is going to be iterating as many as number of clusters. I'm going to be calculating distance for each cluster center. Okay, let's do it. All right. So now I'm going to find the distance. So there are many different ways of doing this part. Okay. So you can try. So what I'm going to do is you can use from SciPy. SciPy is already giving you distance function. You can use it, but I want to do this from scratch. So let's do the distance, find the distance ourselves. Okay. So what I'm going to do is, if you were given x11 and x12, if you were given x11 and x12, let's say D1, okay, you are given D1 and D2, but I'm going to pick the first element of D2, which is this center. So let's say D2, 0. So D2, 0 is the first element. So remember, D2 is the list of the centers of the cluster. D2, 0 is the first center. So I'm going to be doing this between D1 and D2, and then D1 and D2, 1. And then I'm going to do this D1 and D2, 2, right? So I have 3 clusters. So I'll be calculating distance between D1 and D2, 0, D1 and D2, 1, D1 and D2, 2. Okay. Now let's calculate distance between D1 and D2, 0. Okay. So for this, what I'm going to do is I'm going to subtract D2 from D1. Let's call this temp D1 minus D2, 0. So when you do this, this will give you the following. So I'm subtracting D2, 0 from D1. Remember, D1 is x11, x12. This subtraction is going to be the following. x11 minus C11. Sorry, guys. Comma x12 minus C12. All right. So this is what you're going to get when you subtract D2, 0 from D1. This is also a mistake. Thank you. So, okay. You are with me, right? Temp is the difference between these two. Now, what I'm going to do is remember the distance. Look, remember distance. So we subtracted. We already subtracted. Now we found this and this. Now I'm going to take the square root of this, square root of the second term, and add them up. So you can do it separately. What I'm going to do is, here is the following. Here is what I'm going to do. I'm going to do this temp times temp. So what is this? Temp times temp. I'm multiplying 2 vectors. Remember, this is I'm going to treat this as a vector. This is the first member of the vector. This is the second. Temp times temp is going to be the following. x11 minus c11 times x11 minus c11 comma, x12 minus c12 times x12 minus c12. 10 times 10. Okay, again, you see, I am multiplying the first member of this list, this array. Actually, it's going to be an array. Okay, and then I do the same thing for them. Okay, and then if I do this, sum of temp times temp. Okay, not tempo. Temp times temp. So this summation will be exactly this one, right? This guy plus this guy. All right. Okay. And then I'm going to take the square root of this. Okay. Square root of sum temp times temp. Okay. That will be the distance actually, the square root of this whole thing. Okay. I just gave you step by step or what I'm going to be doing here, just one line of code actually. So again, we are going to go through each center. So I'm just going to type the code now. All right. So np.sum temp times temp. Okay. And then I'm going to be taking the summation along the first axis. That means I'm just yeah. So the temp times temp. Okay, and then I'm going to do this temp times a summation. Okay, and then I'm going to let's take the square root of this. Okay. And then put this into a list. All right. So this is the distance. Okay. So this is going to be the distance. And then what I'm going to do is I'm going to append this distance to this distances, the list. So distances and distance. All right. So I found the distance. No, you don't need to. Oh, correct. Temp is, thank you, x1 minus, in this case, d1 minus d2 I. Okay, thank you. C is the center coordinates. Yeah, it's going to be C is, in this case, C is the center of the clusters. Okay. Okay, please, if you see anything wrong, let me know, right? Okay, so this is gonna be giving me a list of distances for this data point. So this data point, it's distance from each and every cluster. And then I put it in a list, okay? And then what I'm going to do is I'm gonna return this, return after this for loop, okay? Return. Distances. But what I'm going to do is I'm going to turn this list. So it's going to be a list of arrays. Actually, this distance, I'm going to show you what it is. It's going to be a list of arrays. So I'm going to turn this into a vertically stacked array. Okay. All right. And then I'm going to take the transpose of this. There is a reason for that. Okay. We are going to get back to this, and or you can try why I'm taking a transpose of this because of the way I'm multiplying or adding the arrays later on. So again, as I said, if I were writing this on a piece of paper, I wouldn't really worry about all these transpose businesses. But because we are going to run this, execute this code, I have to be very careful. Okay, so the random centroids, we are going to generate them when we are working with fit. So this is only for if I give you one data point and k number of centers, how would you calculate the distance between this data point and k number of centers? Right. Okay, now let's fit the data set. Okay, so if I gave you X, the data set, how would you fit this data set? First of all, we already defined number of clusters. So let me call that K is K, okay? Number of clusters. And then I'm going to be using number of iterations. I don't want to use self.number of iterations, so I'm going to do this self.number of iterations. Okay. All right, so I have number of iterations and K. Now, this is the first step that I'm going to be creating the cluster centers. So I'm going to be assigning random numbers to cluster centers. So for that, I will be using this Numpy random choice. Let's say 5, 4. So what it does is, of course, I need to. So what it does is 5 is almost like range of, it's acting like so from 0 to 4, okay? So I'm going to be picking 4 numbers from this array, okay? Random 4 numbers from this array, okay? So here, as you see, I am picking the same number multiple times. So if you do this, replace false, okay, replace false. So as you see, I'm only picking each number once. If you make this true, then there is a chance that you are going to be picking the same number twice. So I'm going to make this replace false, okay? So let's go back here. So now I'm going to be assigning each data point to some random cluster, okay? So let's call this IDs of the data points, okay? So they are going to be, okay, randomly assigned to a set of clusters. So X is my data set, okay? X is my data set. I'm going to create an index for each data point, okay? So this is going to be length of my data set, right? And then I will be assigning, okay, I will be assigning, I'll be picking K number of, so I'm going to be creating an array of K, which is randomly picked from one of these K number of data points. I'm going to be picking randomly K number of data points, and these data points will be the centers, okay, of the clusters. And then replace. So let's do this. Say X is the following. Okay, so let's say X is the following. So you have 3 data points. And then what I'm going to do is Numpy random choice X and then 2. And then what is it? Replace false. Cell list. Can you see anything wrong in here? Okay, so you can pick numbers. So I see length of X. Okay, so I picked 2 and 0. So 2 is corresponding to this guy. 0 is corresponding to this guy. So I picked 2 data points randomly. This one and this one. So the centers, I assume that 2 centers of the clusters from these data points is this guy and this guy. So that's what I'm doing here. Here. So this is the length of my data set. And I'm picking k numbers randomly from this length of data set. And these are going to be the IDs of the clusters. Okay. Next, I'm just going to assign data points that are corresponding to these IDs. And that these guys are going to be the centers, random centers. So X. Okay. So this is going to be my centers that I picked randomly from my data set. No, for clustering, we're not going to use confusion matrix. We are going to be using elbow method most of the time. So I'm not thinking to cover that one. I'm not planning to cover that one. Okay, can you please slow down? So CD is saying, I'm already very slow, I think now. Okay, so up to this point, if you guys have any questions, please feel free to post. Again, it's not so, I know it's not so easy to follow up, especially when someone else is developing the code. It's very annoying, I know that. But let's do our best to understand what is going on. Later on, you can do this practice yourself. I'm pretty sure you're going to do this much better, in a much better way. I already developed the code. I picked the code from different places, put them together. It is working. But again, even I'm typing the code, when I'm typing code, I made a lot of mistakes. I'm not sure after this session, if I run this, it's going to be working or not. I'm not sure about that. Okay. So again, repeating, we picked the indices of the data points that are going to be the random centers of the clusters. And these guys are the centers of the clusters, which are nothing but k number of data points that I picked randomly from my data points. All right. So this is the very first step, guys. We're done with the very first step. Next, now it is time for me to find the distances. Okay. So what I'm going to do is, here is my find distance function. I'm going to use that function. Find distance. Find distance between what? My data points, okay, and the centers. Not enters, centers. Okay. So you see, my data point is not a single data point. I take all the data points. Okay, I take all the data points, and then I'm sending them to this function, and then I'm finding the data points between each data point and k number of centers. So what this is going to be returning, this is the returned array is going to be a list of, let's say if I have 10 number of data points, it's going to be a list of 10 rows. Each row will be the distances between that data point and the centers of the clusters. Okay, let me write what I just said. Assume x dot shape is, let's use some number 200 by 2. Okay, so means I have 200 data points. Okay, let k is 5. Let's say I have 5 clusters. Okay, so what this distance, find distance, is going to return, find distance x and k will return the following. Okay, a list of, let's call it a list of 200 rows. Okay, again, each row is for each data point. Okay, each data point has 1 row, and each row has 5 distance values. Okay, so each row corresponds to a data point, and then At each row, I have 5 distance values. Why? Because I have 5 clusters. Okay, so that is what it is going to be returning to us. So distances will be number of data points by number of clusters. Okay, all right. Now, out of these, for each row, I need to pick the minimum distance for each data point, right? So each row corresponds to each data point. Each data point gives me 5 distances. Whichever is the minimum is the cluster this data point is going to be assigned. Okay, that's what I'm going to do now. From these distances, I'm going to say, let's do this in a loop. Okay, what I'm going to do is for I in distances. Okay, again, distances is a list. For I in distances, now I is a row from distances. Okay, so I picked a row. I is one of the rows from that distances array, okay, or matrix. So I picked I is one of the row. And then what I'm going to do is I'm going to find the minimum argument from this I. What does that mean? Here, okay. Let's say I is correspond to a row, okay. Let's say I is the following: 2, 4, 1, 6, 0. Okay, so there are 5 distance numbers for this data point. This is data I, okay, ith row. So what I'm going to do is numpy argmin I. Okay, so let's do this. Oops, I need to find this. So this, let me also print. So minimum of this list, minimum of I is 0. The argument here is the index of this minimum number is 4. Okay, minimum of I is 0. The index of this minimum number 0 is 4. I'm interested in the index so that I'm going to decide that this data point, which has 5 distance values to 5 separate clusters, actually is at the minimum distance from the cluster with the index number 4. So I'm going to be assigning this index number as the cluster for this data point. That's what I'm going to be doing here. Okay, this is, I'm going through each and every row, and then for each row I'm finding the index of the minimum distance, and that index will be the index for that data point, which indicates its cluster. Okay, so I'm going to be turning this into an array. This is a list. So this is a list. I'm turning it into an array. Okay. So now I assigned each and every data point to a cluster based on that data point's minimum distance from the cluster centers. Okay. So this is the very initial step. I actually randomly assigned data points to clusters randomly. So I'm going to do this in a more, what is that? Iterative manner. Now I'm going to do this in a number of iterations for this range of number of iterations. Okay. All right. So I'm going to do this for a number of iterations. And again, centers. So I'm going to be finding the centers. All right. For each cluster, I'll find that cluster center. Okay. For IDs in range of K. Okay. I'm doing this for each cluster. Okay. Again, I assume that I have K number of clusters. Now I'm doing this for each K. and I'm going to be finding the center of that cluster. Here, I already assigned data points to clusters. Here, I'm going to be finding newly assigned data points, new center. Okay, so let's call this temp center. Okay. From my data points, I'm only going to select from my data point the ones that are assigned to a certain, to this cluster, okay, to this cluster. I'm going to explain what this means in a moment. What does that mean? Let's see. Let's go step by step, okay? For some of you guys, this might be very slow, but I assume that we are all new into this, okay? So that's why I want to go, for each step, I want to go in a little bit in more detail. Okay, so what's happening here is, remember, K is number of clusters. So I'm going to, K is number of clusters. Let's say K is 5, okay? So again, I'm going to be going through each cluster. Let's say K equals, in this case, K is 0. So IDX will be taking the following values: 0, 1, 2, 3, and 4. Because K is 5, in Python, indices begin from 0. That's why IDX will be taking values from 0 to 4, 4 included, 0, 1, 2. Okay, so first iteration. In the first iteration, again, for loop, the first iteration, IDX is 0. Okay, IDX is 0. When IDX is 0, I'm only focusing on the data points which were assigned to this cluster. So where did I assign the data points to clusters? Right here. I assigned, remember, each and every data point to a cluster. And those clusters are taking values from 0 to K minus 1. Okay. So here I'm only going to focus on data points. This is my entire set of data points. I will only filter out data points whose cluster is actual IDX. So this is going to be returning, a Boolean list of Boolean numbers. So okay. Now what I'm going to do is X3. Let's do this way. You see, what I did is, this is my data set. I only picked the data points which are equal to 3. Okay, so I have this one and this one. So what I'm doing here is, I'm only picking the data points whose clusters are, in this case, 0. Okay, so I just take a subset of my data points. So after I do this, I'm right here. I just filtered out my data points. Okay, so the next thing is, I'm going to take the mean of these guys. Okay, I'm just taking the average of these guys. All right, average of these guys. And this average is going to be, I'm going to explain what this means in a minute. So just 1 second. So there isn't any folder to share. So we're just typing the code together. I didn't share any folder. Okay, so let's talk about this one, mean. Okay, what does that mean? And X is 0. So remember my data sets, X dot shape is giving me number of data points, number of features. Okay, so I have some number of data points, and each data point has a number of features. So if I do this, X dot mean x is 0, okay, if I do this, what I'm doing is I am taking the mean of each feature across all data points. Okay, so think of x as a matrix. If you're taking the mean of x based on x is 0, you are taking the mean of each column. Okay, if you do this one, then you are taking the mean of each row. Okay, so here I'm interested in, after I filter out data points which belong to the same cluster, I'm interested in taking the mean of each column. So that is going to turn, in this case, if I do this, it's going to return the following. A point, let's look at a point with, so x.shape, number of data points, let's call it n, number of features, let's call it p. So a point with p dimensions. Okay, so that's what it's going to return. Okay, let's go back to our example here. So this temporal center is the center of data points belonging to the same cluster, and it's going to be only if it is 2 dimensions, 2 dimensions, 3 dimensions, 3 dimensions. Okay, so we found the center. All right, now I'm going to append centers, append center. Okay, center. So I found the center for the first cluster, then the second cluster, then the third cluster. So as I find the centers, I'm just appending it to this empty list. So at the end, I'm going to have the center for k number of clusters. All right. So after I'm done with this, what I'm going to do is I'm going to say number of clusters, so cluster centers. I'm just creating a new variable, cluster centers, will be centers, okay? Will be the centers. So I'm just going to, again, turn this into a list. Okay, so this is my cluster centers for this iteration after I go through my data set for each cluster. Again, this is for this iteration, All right, so I'm going to be doing this for many iterations. So this is for this iteration. At each iteration, I will be updating my center. Okay. So I found my centers. Okay. So the next step is for these new centers, I'm going to find the new distances. Okay. So distances will be, I will be using my find distance. By the way, let me also use self dots. I'll be using my find dist function. Okay. This time, here is my data set. And earlier, centers were this, which was randomly assigned. Now I found new centers. So I will be doing this for the new centers. Okay, guys, please pay attention to this one. So initially, I created randomly assigned centers. But after I go through this iteration, I have the new centers, which is the mean of the data points that I already assigned to clusters before. Okay, so now I'm finding this distance between each and every data point and these new centers. Okay, this is the new distances. And then again, I'll be repeating this step, okay? But this is going to be the labels after I go through these iterations. So these are the labels for my data points after I go through this iteration. So I'm just going to copy this. Okay. Yeah, Stephen, thank you. I corrected that one. I just saw it. All right. Thank you for your feedback, guys. Okay, so this is completing what I'm trying to find out. So, and then let me return. When I say return self, I'm returning these labels, these cluster centers. So later on, I can call this. Here, when I fit Kmeans, I can say this, Kmeans 1 dot, what was the name? Labels. Okay, if I do this, it's going to give me the labels for all the data points. I can also do this. Kmeans dot, what is it? Cluster centers. This will give me the latest cluster centers that I found for my data points. All right. I think we got tired, right? Okay, so this is, let me just quickly type the predicts and then we'll be done. I know that it's more than what I planned. So I'll be done in a minute, okay? 5 minutes. So now, what if I give you a set of data points and then I ask you to predict the cluster for this data point, okay? Again, what we are gonna do is we are going to calculate the distance between this data point and all the cluster centers, okay? So, and then I'm gonna decide whether this cluster belongs to, whether this data belongs to that cluster or not, okay? So again, K is self K, okay? So because I need to know the clusters that I have, all right? And then centers is, these are the centers of the clusters, cluster centers. Okay. And then let's, actually, I may not need K here, so let me just this one. Okay. So for these centers, I'm going to calculate the distance. So distances is self find distance. I already got this find distance. Actually, I can just copy this. Okay, and yeah, this is the new data point X. Let's use small x. So it's a new data point. I'm finding the distance between this data point and each and every center. Okay. Okay, I found the distances first, and then the label for this data point will be, again, I'll use this one here. This one. The minimum of the distances, right? NP argmin, the minimum of the distances. I can have number of data points or a single data point. Okay, I can have number of data points or a single data point. So I find the labels for these data points. Okay. All right. I think we are done with this class. I hope it's going to work, but let me check one more time very quickly. So here I'm running this. So this one is finding me the centers. Find the centers. Should this label be self-labeled? Let's call this way. Again, you don't need to write this 2 times self-label, but I just want to make this as readable as possible. So I might have made some mistake here. I'm going to share the code that I already did and ran, and then it's working. I'm going to share that with you. Share this file and my file so that you can compare. Again, you can still find some mistakes, small mistakes, which is fine. Okay, let me know. But I think this is all that. Let me open my file here. Just 1 second. Yeah. Let me see. As you see, I didn't talk about this part, because this part I'm still trying to do it. So let's run this. Let's just 1 second. Distance. Okay, let's run this. So here, as you see, I'm just instantiating my K-means for a number of Ks, number of iterations, and fitting data, but data is not here. So let me see. So this is data. Let me get rid of this guy. Okay. So what I'm using is I'm using data from scikit-learn, and for that, just 1 second, guys. This. Okay, I'm using the digits dataset. If you guys came to any of the sessions before, you must remember we use digits dataset, MNIST dataset, which is available from scikit-learn. I'm using that dataset, but that dataset, each data point has 64 features. So because of that, I got this part from somewhere else. Because of that, we are using principal component analysis, reducing number of 64 features into 2 features to make things simple. So each data point has now 2 features, and here each data set has 2 features. And now I'm calling the function, the class Kmeans, and then creating the labels and then plotting the labels here. So there are 10 digits, and then we had 10 clusters. Okay. Again, there might be some small mistakes. I'm going to check one more time before I'm going to share with you. Just 1 second. There's a small mistake here. Where is it? Label. F. Okay, so it's essentially it's X. Oh, I see. It should be capital X. Where is it? Okay. Which find distance? Okay, distance is step 2. Okay. Yeah. Thank you, Edward. Yeah, we got it. So I'm going to share this code with you. Again, I just saw one small mistake here. So here, when I'm finding distance, I should have taken the square root of this term. I'm going to fix it. Other than that, I think it is working fine. I'm going to share this with you. I will also work on this one to make sure that it is working. So maybe some other time we can work on this. So this is calculating the cost for a certain number of clusters. And then we want to decide which number of clusters will be the best for assigning our data points to that number of clusters. So this part I couldn't finish. I was working on it. Anyways, so let me stop here. I know that you guys are tired. I'm also tired. Thank you for listening. I'm going to share 2 files with you. One, this solution. Second one is this file that we practiced together. Okay. I promise we are going to meet for logistic regression. I already created the files for the class, but my schedule was I couldn't give the lecture anyways. So thank you for listening. I'll see you next time. Take care, guys. Bye.